3I Atlas did not explode. And the new images don't just confirm its survival, they show something even stranger. 3I Atlas is only the third interstellar object we've ever found, and somehow it keeps getting harder to explain. Its close pass by the sun should have answered the big question everyone's been quietly arguing about since summer. Is it natural or something technological? And right now, most astronomers still say it's an extreme but natural comet. But a small minority, like Harvard's Professor Avi Loeb, insists the evidence points to something far stranger, maybe even technological. So when 3I Atlas passed perihelion, everyone expected the new images to settle this debate, push the story one way or the other. Instead, the days after the sun encounter gave us the strangest images yet. The first shot came on November 8th. A deep stacked photograph showed a glowing halo spreading nearly 500,000 kilometers across, and at least 7 distinct jets fanning outward from a nucleus only a few kilometers wide. And the real shock came the next night. In the early hours of November 9th, 2 European telescopes captured a much deeper, wider field. This time, the jets didn't just flare near the nucleus, they stretched across space for staggering distances. 2 bright jets pointed roughly toward the sun, each approaching 1,000,000 kilometers in length, and on the opposite side, a long, thin tail extended close to 3,000,000 kilometers, several times the Earth-Moon distance from an object barely 5 or 6 kilometers across. Images like that force a pause, because if the jets are that long and that structured, they're not momentary bursts. They're sustained, and sustained jets require power, a lot of it. This is where the debate cracked open. In the natural comet model, the mechanism is simple. Sunlight heats the surface, ice turns to gas, the gas escapes and forms jets. But here's the problem. To sustain jets of this length and clarity for weeks, 3I Atlas would need to absorb the same amount of energy you'd get if 1,000,000 nuclear power plants all ran at full power for an entire month. 3I Atlas can't absorb even a fraction of that. The entire object is only a few kilometers across, far too small to collect enough sunlight to power jets on this scale. There just isn't enough surface area. Mainstream researchers counter that the jets might not be as massive as they look, that brightness doesn't equal density, and that the structures could be very thin, very diffuse plumes that only appear dramatic. But the minority pushes back. If the jets were truly that light, they wouldn't hold their shape over millions of kilometers, and they wouldn't visibly push against the solar wind the way these appear to. So the energy mismatch stayed unresolved, and right in the middle of that disagreement came another twist. On November 11th, the Nordic Optical Telescope captured high-resolution images focused directly on the nucleus. If the earlier jets were as intense and long-lived as they appeared, you might expect to see the aftermath: cracks, fragments, debris peeling away. But instead, one clean nucleus, no fragments, no debris trail, nothing that looked stressed or torn apart. For mainstream comet specialists, this wasn't alarming. Plenty of comets survive heavy outgassing. But for the minority group, this was the strangest part yet, because if the November 8th and 9th jets were as strong and persistent as the images suggest, then an intact nucleus shouldn't be the default outcome. Strong, uneven jets acting on a small body usually leave marks: changes in spin, surface loss, cracks, a debris field. Here, nothing but an astonishing intact nucleus. And the November 11th image carried another clue: a strong sunward tail, another anti-tail, almost identical to the one Hubble recorded back in July. Anti-tails can be explained naturally. But seeing such a strong, persistent one twice, months apart, on a small, heavily active body raised eyebrows again. You can explain a single oddity. Explaining the same oddity twice is harder, and then came the radio detection. Using the Meerkat radio array, scientists picked up hydroxyl emission, the classic fingerprint of water molecules breaking apart in sunlight. This is textbook comet behavior. So mainstream researchers took it as confirmation. Whatever else is going on, 3I Atlas is releasing water, but the minority never denied the presence of gas. Their question is, how much? How fast? And what realistic process could be powering activity at the level we're seeing? The radio detection doesn't answer that, it just confirms water is involved. Not how extreme the outgassing is, or whether the jets behave like random vents or something more directed. And that's where the debate sits today. One side says 3I Atlas is a natural but extreme comet, a rare visitor showing us what comet physics can do under intense heating. The other side says natural explanations are stacking up too many exceptions. A strong anti-tail, enormous jets, an energy budget that doesn't add up, and a nucleus that looks completely unharmed afterward. They argue that if some of the jets behave like directed exhaust, then the contradictions disappear. The nucleus stays intact, the jets stay long and coherent, and the energy requirements drop dramatically because you don't need the sun to power a propulsion system. Mainstream astronomers dismiss that idea as unnecessary speculation. The minority counters that stacking a long list of rare but possible explanations starts to feel like speculation too, just in a different direction. Who's right? We don't know yet. Over the next few months, as 3I Atlas moves farther from the sun and closer to Earth, astronomers will gather new data, better spectra, sharper imaging, and, most importantly, direct measurements of the jet velocities. If the jets turn out to be slow and diffuse, the natural explanation wins. If they're fast, narrow, and sharply directed, the technological interpretation becomes much harder to ignore. For now, 3I Atlas continues on its path, jets burning, halo glowing, a small visitor from another star carrying some of the most unbelievable questions of any object we've ever studied. Is it simply a wildly active comet pushed to its limits? Or is it something else? Something built, guided, or steered? We don't have the answer yet. But whatever it turns out to be, it will change how we understand visitors from beyond our solar system. Thanks so much for watching. If you enjoyed this deep dive, a like or comment really helps the channel. And if you want to follow this story as it unfolds, feel free to subscribe. I've got more coming soon, and I'd love to have you along for the next one.